In this section, we'll start talking about loops, and specifically here, the for loop, and later we'll get to the while loop. As we saw with the conditional statements, the if statement, loops, if statements are common to most programming languages that you're going to encounter. So this is transferable to things like C or Java or Python, and if you know any of those languages, then this should look familiar to you as well. In contrast to the if statements, which ran only certain sections of code if the statement was true, what a loop is going to do is repeatedly run the same block of code over and over again, although within that block some things can change, as we'll see in a little bit here. So we can set up the general statement to make a for loop like this. So to begin our for loop, we use the word for, and then we have some index. In this case, the index is k. We have a start point, and we have an end point, and then optionally, but here I'm putting explicitly, we have the how much we increase our index per loop. So we're going to start the value of k at 1. Every time we go through a loop, we're going to add 1 to it, and then it's going to stop once k is equal to is over 10. So it will run it the 10th time, but then it will exit the loop. And then inside here, we're going to put the instructions for what we want to do inside the loop block. For this first example, I'm just going to display the value of k. So if I run this, it's going to repeat this command of displaying k 10 times. So let's see what happens when I run this. So we see it displayed the value of k. So the first time through, k was equal to 1. It got to the end. I'll just put a comment here. So when it gets to the end, the value of k is increased by 1, and we go to the top of the loop here, and then repeat that instruction again. But what's happening, again, every time it goes through that for loop, the value of k is increasing by 1, and that's what it's doing, is printing it on each iteration of the loop. So we go through, k is equal to 10, we get back up to the top, and now k is larger than that last value here of 10, so we exit the loop. Like when we were making vectors before, we can also change that step size, we call it. So how much does k change on each iteration of this loop? So for example, if I make it, it's going to increase by 0.2, then every time we get to that end statement, the value of k increases by 0.2 until we're at 10, it goes greater than 10, and then we exit this for loop. By default though, if I go back here, if I get rid of that middle number, if I get rid of the step size, it defaults to 1. Even though we can use step sizes other than 1, most of the time that we use these for loops, it is going to be preferable to do it inside by iterating by only 1. And we'll see why that's so, because when we use vectors or we use matrices, oftentimes what we want to do is refer to one of the elements in the matrix, and the elements of the matrix can only be referred to by integer numbers. So one way we can use a loop is we can say, take a vector here, I'll make x a vector from 1 to 10. Get rid of this display for the moment here. Right, so if I see x, I have the numbers 1 through 10. And I can say, using this loop, I can say that y of k is going to be x of k squared. Okay, so I'm making a vector y, and I'm going to fill in the elements of y based on the square of the element of x. So for example, on the first iteration, when k is equal to 1, I'm saying here that the first element of this vector y is going to be equal to the first element of the vector x squared. Looking back at how x is defined here, the first value of x is 1, so the first value of y should be 1 squared. We get to the end statement, and we loop back up here, and k is increased to 2. So then we say that the second element of y is going to be the second element of x squared. So that's 2 squared, so we should expect that the second element of y is going to be 4. And I'll not suppress it for right now. Let me just run this. Right, so we see that the way it's working here is that that vector y is growing on every iteration of the loop. So at first it only has one element, then we add a second element, a third element, and so on, until y has all 10 of its elements there. Let's just see what happens if we use a non-1 as our step size. So if I try to make this 0.2, it's not going to work, because it's going to try to refer to x of 1.2, 1.4, and we can't do that when we're referring to elements of a vector. So it doesn't like to do that. So I would say, for the most part, make sure that the step size is 1, and we'll see how we can still work within those confines in a couple of slides here. Right, so I rerun this, and I see that I get, again, at the end of this iteration, I have 10 elements in y. And we can combine here our for loops. We can have combined if statements as well. So I can say if y of k greater than 5, then I want to display y of k. So I can have if statements within my for loop. So here it's assigning those values for to y, and then it goes through within this loop, it goes through this if statement. So it's going to say if the kth value of y is greater than 5, then I'm going to display y, but not do anything otherwise. We see here that kind of the formatting got a little out of place, but Matlab has a nice feature that if I select a block of text and hold Control and push I, it's going to do what they call a smart indent, where it will kind of line it up a lot nicer. So if I run this new block of code here, what it's doing, it's only displaying when the value of, when y of k is greater than 5, it's displaying the value y of k. So it's not showing y of 1, it's not showing y of 2, it starts with y of 3. If I increase this, let's just say to 18, and rerun this, we see again it's only displaying the values when y of k is greater than 18. Going back to the first example, let me get rid of this if statement right now. Going back to printing this, the way I have it set up now, I'm assigning a value to the kth value of y. In this case, k is only going to 10. What we see is on every iteration, the size of y is increasing from 1 element to 2 elements to 3 elements, all the way up to 10 elements by the time I'm done. This is actually a relatively slow process if the size of y, or whatever vector you're working with, or matrix you're working with, changes within a loop. So let's do this not for 10 iterations, but actually for more iterations, and just see how this is going to be affected. So let me run this for 100 values of y. And I'm going to start suppressing this just so we can see how it's working. So I can look at here, if I put a tick and a talk, I just want to see how long does this for loop run. Right, so for this size, it runs very, very quickly. It's not really a concern, but if we start to increase its size, right, so I'm running y 1 million times, and we see it takes 0.38 seconds. I'll run this a couple more so we can get an average here. It keeps taking about 0.38 seconds to run this block of code. And remember, the way I wrote it now is y starts as 1 element, that becomes 2 elements, then 3, etc., until in this case it goes up to 1 million elements. That resizing of y is very time consuming. One way that we can help this is by pre-allocating vectors or pre-allocating matrices. So in this case, I'm going to kind of create y up front. I'll do it actually after the tick for comparison. So instead of just the program not knowing how big y is going to get, I can make y initially a vector of zeros, 1 million long. Okay, so I'll unsuppress this, so it prints it all out here. It's a lot going on. If we go into the command window and press Control-C, we can break a current running code, which is sometimes necessary if you make a mistake or if it seems to be kind of stuck in somewhere. So let me get rid of that. I don't want to display that anymore. All right, so if I run, so again, y has 1 million entries. Initially, they're all equal to 0. But let's see the difference when we pre-allocate, when we make y the same size as it's going to be after it exits the for loop. And I run this block of code. Right, we see here, I'll run it a couple more times. When we pre-allocate, then this code takes about 0.025 seconds to run. Let me comment out line 52 and rerun this. So in comparison, it takes 0.38 seconds without pre-allocation. Again, with it, 0.02 about. So with pre-allocation, or without pre-allocation, I should say, it takes about 19 times as long for this piece of code to run. Now, appreciably, we can't really tell a difference between 0.38 seconds and 0.02 seconds, but if you imagine larger pieces of code, if we can get a 19 times speed up, if normally a program would take 19 minutes to run, and then by doing something fairly simple like pre-allocating, it now takes 1 minute to run, that's going to be a huge difference that we're going to see in the end. Just as we can put if statements within for loops, we can actually put more for loops within for loops, or a nested for loop. So we want to choose a different index here. Here in my outer for loop, I have an index called k, and here for my inner one, I'm going to use j. Often standard indice choices are I, j, and k as you name them, but you do want to be careful with using I and j, since Matlab does understand I and j also as the square root of -1. Alright, so let's have an inner for loop and see how this behaves. So what's going to happen is, let me close that for loop then. I have my outer for loop iterating on k, my inner for loop iterating on j. And I'm going to get rid of these statements here and make this a lot smaller. And I'll get rid of this as well. Alright, so my outer for loop, I'm displaying my value of k. On my inner for loop, I'm just going to display my value of j. Now again, in this nested for loop, let's see how the program is going to behave when we go through this. Alright, so we're going to get into our outer for loop, where initially the value of k is going to be equal to 1. It's going to print that value of k, but then the next command, it actually enters this inner for loop, where it's going to do the entire inner for loop before it proceeds back out to the outer for loop. So within this inner for loop, it's going to iterate j from 1 to 5 and print it out each time. It then exits that for loop once j is greater than 5. Then it goes down to this end statement where it's going to add 1 to the value of k, come back up to the top, k is now 2, it will print 2 since k is now 2, and then once again enter this inner for loop. So every time it goes through the outer for loop one time, it completely will go through that inner for loop. So let's see what happens when I run this. Just so we can differentiate, I'll print loop on the outside one and print the value of j on the inside one so we can see the difference here. So if I scroll up in my command window, we see it hit that first loop. It did the entire inner j loop, went back to the outside loop, so it printed loop again, did the entire j loop again, etc. It keeps repeating this until we had a value of k that was greater than 10 when the program finished. Now we're going to see this is useful when we are trying to handle matrices. And one other thing we can do is within this inner for loop, I can actually have the end condition change as I go through that outer for loop, and we can see what happens here. So now, initially k is equal to 1, it's going to print loop. It goes to this inner loop, but now j is going to be 1, will be good until j is greater than, on the first iteration, 1. Then we circle back again and the value of k can change, and now when I go through my inner for loop, my end condition is now different because k is now different. So if I run this, I go up to the top of my command window. I see it only went 1 time, then 2 times, 3 times, 4 times, so it kept changing as we can predict when the value of k changed. And finally changing it one more. If I do want to change the step size on k, and we rerun this, we can see in similar fashion that it's going to change the behavior of the entire loop starting at 1, but then k goes to 3 on the outside iteration, then 5, 7,